So, hello, dear students. Today we will solve the UT1 physics paper, uh, which was held today. So, students, the question paper is on the screen. And today, students, we will solve only section A. And in next class, we will solve section B. So, yeah, this is section A. And question 1 is MCQ. First question is like this. You can just see a metal bodied electrical appliance is connected to a domestic power supply using a 3-core cable following the latest color coding standards. During operation, a fault causes the live wire to come into contact with the metallic casing, which wire ensures user safety by carrying the fault current to the ground. And what is its color as per the modern convention? So students, here I have taught in the class also, students, which wire we connect with the metallic part? Earth wire we connect, na? Earth wire we connect with the metallic part. And students, this earth wire, it carry the fault current to the ground. And students, we have to tell what is its color. So its color, according to the modern convention, is yellow. So option C will be the correct. Now next. Now friends, here you have to tell which compass depicts the direction of magnetic field of the straight current carrying conductor correctly. So here it will be B. Option B will be the correct answer. Next. Next is students, the fuse wire is prepared from which material? This also I have taught in the class. It will be lead and tin. And now student, fourth is when a resistance wire is stretched so that its length becomes double, its resistance becomes 4 times its original value. And reason R is given. This is a adjacent region problem. The specific resistivity of a wire is directly proportional to its length and inversely proportional to its cross-sectional area. So first, students, first we will see whether our assertion is correct or not. So here, students, what they are asking, when the resistance wire is stressed, so that its length become double and its resistance becomes 4 times its original value. So students, as we all know, what is the formula of resistance in terms of length and cross-sectional area? It is R dash is equal to L dash upon A dash. And students, when your length will become double, that is L dash, if it will become double, twice of L, and then what will happen if length will double? Then area of cross section will be half. A dash will be half. So put all the values in the formula. So here, friends, R dash, it will be equal to how much? Twice L upon A by 2. So here you will get 4L by A. Here you will get 4R. So here, students, resistance is how much it is coming? It is coming out to be 4 times its original value. So students, here assertion is correct. And see for region, they have given the resistivity specific resistance of a wire is directly proportional to its length and inversely proportional to its cross sectional area. So students, this is wrong. Resistivity do not depends upon the dimensions of a conductor, that is length and cross sectional area. Resistivity depends on material property and temperature, and it depends on temperature of the conductor. So students, your region R is false and adjacent is true. So option C will be the correct answer. A is true, but region R is false. In this way, you have to solve this problem. This was a little bit tricky, but this is simple based on concept. So if your concepts are clear, you can solve this problem. So next is a heater coil is cut into two equal parts, and only one part is now used in the heater. The heat generated will now be, assuming potential difference is same in both cases. So here, students, we will see. We'll proceed for the solution. So here, students, here heater coil. There is heater coil, and it is cut into two equal parts. There is a heater coil, and the students, suppose that this is the length of the heater coil, and students, if it is cut into two equal parts, then what will happen? Its length will become half. So here, its length will become half, and we can write this L dash is equal to L by 2. And since, as we all know, resistance is directly proportional to length. So students, if length will become half, then resistance will become how much? It will also become half, because resistance is directly proportional to length. And now, students, uh, potential difference they have given, that potential difference is same. So here, students, what will be current? I dash, it will be V upon R dash. Is this clear? So here put R dash is equal to R by 2. So here it will become 2V by R. So we have got current this. Now, students, we will use the formula of heating effect of current. What is that? H is equal to H is equal to H is equal to I square RT. Is this clear? To dash here, I dash square R dash T. So here H dash will become how much? I dash square, how much it is coming? 2V by R. So it will become 4V square by R square into R dash is R by 2 into time. Now, friends, here H dash will become how much? 2, 2 will go. Then here we will be left with 2V square by R square into R into T. And now, friends, as we all know, H dash V square upon R square. This is how much? It is current. So here it will be 2 I square R T. So students, we have got in terms of original heating effect of original heat energy. So here H dash is equal to how much? Twice of H. So your heat energy has become how much? Heat generated has become how much? Twice of the original value. So here, students, option C will be the correct answer. Now, students, Ohm's law is valid only when Ohm's law is valid only when temperature is constant. This clear? So temperature should remain constant. So option C is the correct answer. Now, friends, seventh, why are electrical appliances rated in watts to measure power consumption? Power consumption, students, we measure in electrical energy or power which is consumed in our homes. We measure in kilowatt hour. So, students, that's why our electrical appliances are rated in watts to measure power consumption. So option B is the correct answer. So this was all about 7. Next, 8th. Now next. Now a student connects 3 resistors, 2 ohm, 2 ohm, 3 ohm, and 6 ohm in parallel across a 12-volt battery. He then removes the 6 ohm resistor and reconnects the circuit. What will happen to the total current drawn from the battery? So, students, we will calculate this. So, we'll proceed for the solution. Here, current we know The current will be equal to voltage upon equivalent resistance of the circuit. So students, here we will calculate the equivalent resistance of the circuit. R equivalent. It will be how much? It will be equal to 1 upon 2 plus 1 upon 3 plus 1 upon 6, because 2 ohm, 3 ohm, 6 ohm are given. So here students, the next step will become 1 upon R equivalent. It will be equal to 6, 3 plus 2 plus 1, 6 by 6. It will be equal to 1. So here students, your R equivalent, total equivalent resistance of the circuit, it will become 1 ohm. So here students, your current will become how much then? Your current will become how much? V upon R equivalent. So your students, your current will become 12 volt upon 1 ohm. It will become 12 ampere. It's clear? Now for next they are saying if he then removes the 6 ohm resistor and reconnect the circuit, right? Again, we will calculate the equivalent resistance for this. Yeah, we will calculate equivalent resistance of the circuit. Here 1 R equivalent, it will be equal to how much? 1 upon 2 plus 1 upon 3 additions. It will be equal to how much? 6. 3 plus 2, 5.6. And R equivalent will be equal to how much? 6 upon 5. Now next we will calculate current. So here friends, this current will become how much? 12 volt upon equivalent resistance, 6 upon 5 upon 6 upon 5. So it will be ohm. Here it will become 60 volt upon 6 ohm. And here friends, we will get 10 ampere. So friends, current has decreased. Is this clear? Current has decreased. And why current has decreased? Simply, students, equivalent resistance of the circuit has increased. So if resistance will increase, current will decrease. So the correct answer for this will be, it will decrease. Option A will be the correct answer. Now, friend, next is ninth question. A student uses an electric kettle rated 220 volt, 1000 watt in a hostel where the supply voltage sometimes drops to 200 volt due to heavy load. Assuming the resistance of the kettle remains constant, what will happen to the power consumed by the kettle when the voltage drops? Now, friends, we'll proceed for the solution. So, here, friends, resistance is constant, but voltage is decreasing. And we know one relationship between power, voltage, and resistance. What is that? P is equal to V square for R. So here, friends, resistance is constant, and if voltage drops, then what will happen? Power will also drop. Is this clear? So here, friends, what will be the correct answer? Power will decrease. And in household ring system of wiring, appliances are connected in parallel combination. So B will be the correct answer. So this was all about the MCQ. Some were very easy, some were little bit tricky. So you need to have good command on your concepts. Now, question 2, first part. Fill in the blanks. Two copper wires can have the different area of cross section. Will have same. They have same resistivity, because resistivity do not depends on the area of cross section. Now, student, the strength of magnetic field around the current carrying wire, it can be increase or decrease by decreasing the current through the wire. It will be decreased. Now, students, an electromagnet is prepared from which material? Electromagnet is prepared from which material? It is prepared for, students, soft iron. It is prepared from soft iron. This we have studied in the class. The resistance decreases with increase in temperature for a semiconductor. And students, fuse wire has high resistivity. This also we have studied. The direction of magnetic field is given by which rule? Right hand thumb rule. The direction of magnetic field is given by which rule? Which rule? Right hand thumb rule. Now next, if the direction of current in the coil is reversed, the poles of electromagnet will also reverse. According to the right hand thumb rule, if current is flowing upward, then magnetic field on the left of the conductor will be. Students, we have to tell, we have to apply here right hand thumb rule. If current is upward, then in this way, this is the direction of magnetic field. Na? Student, this is what? This is inward, and this is what? This is outward, and this is the left part of the conductor, left region of the conductor. So here it will be what? Outward will be the correct answer. So here outward to the plane. Now, friends, next they are asking soft iron is used as a core in an electromagnet because it has high magnetic permeability. This also we have studied in the classes, was also very simple. The main advantage of an MCB over a fuse is that it responds more quickly to the abnormal current. If there is high current in your circuit or abnormal current in your circuit, then what will happen? It will react more quickly. Okay. So this was all about the fill in the blanks. Now come to question number 3. The VI graph for a series combination and for a parallel combination of two resistors is shown in the given figure below. Which of the two, A or B, represents the parallel combination? Give reason for your answer. So students, if you will calculate resistance here, uh, resistance is how much? Resistance is V upon I. And students, if you will calculate the slope of this slope for A and B, slope for A will be how much? Slope, if you will calculate slope for A, it will be greater as compared to slope for B. Slope for B, is this clear? Slope for A, it will be greater as compared to the slope of B because see, Y coordinate will be high. Voltage, sorry, voltage coordinate. If you will take some voltage here and here, so voltage coordinate is greater for A as compared to B. So your slope will be high. Is this clear? Your slope will be high. So students, slope for A, it is greater than as compared to slope for B. And students, they are asking for parallel combination. In parallel combination, resistance is decreased. Is this clear? And students, slope here, if you will calculate slope here for this graph, it will be V2 minus V1 upon I2 minus I1, and it students, it is equal to the resistance. And students, resistance will be, slope will be less for which, A or B? Slope will be less for B. So resistance will also be less for B. So students, here parallel combination represents which will represent parallel combination. B will represent parallel. So this was the correct answer for this. Now, friend, next is a wire of resistivity rho is pulled to double of its length. What will be its new resistivity? Write the SI unit of resistivity. So, students, resistivity do not depend on dimensions of the conductor. Resistivity do not depend on dimension of the conductor. Resistivity only depends on temperature, temperature, and temperature and property of material. Property of material. If you will increase temperature, then resistivity will increase. And students, for different materials, resistivity has different values. Conductors have low resistivity, insulators have high resistivity, semiconductors has intermediate resistivity. The resistivity of semiconductor lies between that of conductor and insulator. So students, resistivity, there will be no change in the resistivity. Resistivity will remain same. And so they are asking what will be the SI unit of resistivity. So students, R is proportional to L. R is inversely proportional to area cross section. If you will combine this, L upon A, and it will become R is equal to rho L upon A. This constant rho is called the resistivity. And students, this is equal to rho is equal to R A by L. What will you student? The unit of resistance is ohm. Area meter square upon meter. So it will be how much? Ohm meter. This is the correct answer. That's a unit of resistivity, ohm meter. Next, come to the next one. Now, friend, next is observe the following diagram and identify the type of device named as Y. Also convert the given reading into SI unit of energy. Student, Y is which device? Y is electric meter. And students, we have to convert the given reading into SI unit of energy. You see how to solve this? What is the reading? 3528 is the reading. 3528. And students, we calculate our cons consumed electrical energy in which unit? What is the commercial unit of electrical energy consumed? Kilowatt hour. So here it will be 3528 kilowatt hour. We have to convert into SI unit of energy. So students, we have studied in the class 1 kilowatt hour is equal to 3.6 into 10 to the power 6 joule. So here it will become 3528 into 3.6 into 10 to the power 6 joule. So here students, it will become 3528 into 36 into 36 upon 10 into 10 to the power 6 joule. So here students, if you will calculate this, how much it will come? 127,008 into 10 to the power 5 joule. And students, if we will write it in more concise form, 1, 2, 3, 4, 5. So here it will become 1.27 into 10 to the power 10 joule. So this is the correct. So this is the final answer. Now next. Now next they are asking, state the potential difference and frequency for domestic electrical energy. So as you all know this, 50 hertz, 220 volt. This is very simple. Now the diagram shows a loop of wire carrying current I. What is the magnetic polarity of the loop which faces us? What will be magnetic for polarity? So here see, the direction of current is clockwise or anti-clockwise. If you will see, the direction of current is clockwise. So here what will be magnetic for polarity? It will be south pole. Is this clear? It will be south pole. And now they are asking with respect to the diagram, how we can increase the strength of magnetic field produced by this loop? By increasing the current. If we will increase the current, then we can increase the magnetic field. And students, uh, and if you will place a soft iron inside the coil, then also what will happen? Magnetic field will increase. And if you will decrease the radius of this coil, radius of this loop, then what will happen? A smaller loop will give stronger magnetic field. A smaller loop will give a stronger magnetic field. So in this way, you can also increase the magnetic field. So this was the solution of this problem. Section B, we will solve in the next one. That's all. Thank you.